Alright, let's do number 13. A roller coaster car moves 200 feet horizontally and then rises 135 feet at an angle of 30 degrees above the horizontal. It next travels 135 feet at the angle of 40 degrees downward. What is its displacement from its starting point? I encourage you guys to pause this video and to give this problem a shot. So the roller coaster initially, let's see if I can draw this, moves 200 feet, which I'm going to call vector. I'm going to call this V1, I guess, because that's the direction, horizontally. And the magnitude of V1 is going to be 200 feet above the horizontal. And then rises at an angle of 135 feet. So it rises at this angle, and the magnitude of this vector is going to be 135 feet at the angle of 30 degrees above the horizontal. It then next travels 135 feet at an angle of 40 degrees downward. What is its displacement? So 135 feet, it's going to travel a little, I think it's going to travel a little less according to this. So it's going to travel a little extra 10 feet down. So downward, so it's going to travel, it's going to pass that point. So I think it's going to travel like here. I'm not sure though. Probably a little downward. So, and this is going to be B3. And B3 is going to be, the magnitude of this is going to be 135 feet at 40 degrees. And notice that you can really draw these components together, folks. And the overall displacement is from this point to wherever that end point is. That's what we're going to be looking for. So I encourage you guys to pause this video and to give this problem a shot. You can find it graphically. I'm not going to do that. I'm just going to, put it on the calculator, but you can do whatever you guys want. It's the same thing, really. So we're going to find its displacement, and then we're done. So its displacement is going to be 200 feet. So the vector that we're looking for, which I'm going to call X and Y, so I can keep track. X is going to be 200 feet. And then we're going to take the magnitude of 135 feet, and we're going to add the cosine component of this. So this is going to be 200 feet. This is going to be V2 cosine of 30 degrees. And then we're going to add, or minus, I guess, since we're going to go downward, 135 feet cosine of 40 degrees. And that's just X, folks. And Y, we're going to, initially it's going to be 0 feet. I'm an idiot. It's actually plus. It's hard to do video and keep track of this, but yeah. So we're going to write 135 feet sine of 30 degrees. And we're going to minus 135 feet sine of 40 degrees. There we go. All right. So we're just going to put that in the... All right, folks. So I did put it in the calculator, and I have 420.78 feet at the angle 2.63, which matches the answer in the back of the book, but it doesn't answer to the match when I did this on my own, which means I messed up somewhere. But if I've made a mistake, please correct me. But the straightforward process is you take the components and you add them up. So that should be straightforward enough.